Episode 6 of the Electromagnetism series. In this, we're going to be giving the summary of what we studied in episode 5. In episode 5, we talked about how to use the right-hand rule to find the direction of the magnetic pole and the magnetic field lines on a solenoid. We're going to always start by using our fingers, pointing our fingers in the direction of the curls on the coil, and using that, keeping that same position wherever my thumb points. This is the direction of the North Pole, and opposite to my thumb, this is the direction of the South Pole, okay? And we said that the magnetic field lines always from North to South Pole, okay? Always. So, thumb will be the North Pole, opposite will be the South Pole. You draw the magnetic field lines from the North to the South, okay? Then we have talked about the magnetic field around a solenoid. If I want to increase more the magnetic field around the solenoid, what can I do? We started by a long wire that we have put together, coiled it up to increase the density of the field lines. I can actually increase more coils, curl it up even more, loop it up even more, okay? So number of coil turns, increase it even more, directly proportional, more magnetic field. Amount of current supplied. We said current induces magnetism and magnetic field. So if I supply more current, we're going to have a stronger magnetic field around the solenoid, so it's also directly proportional. What about the distance? For example, two magnets, as I'm increasing the distance between them, magnetic field between them is getting weaker, okay? So this means that it is going to be inversely proportional. To have a strong magnetic field, I need them to be close to each other. As one increases, other one decreases by the same rate. And last but not least, we need the soft iron core. Soft iron core is actually going to increase the magnetic field. And actually, when we're drawing the solenoid, by the way, this square that I draw the loops around, this itself is the soft iron core. Soft iron core, okay? So, why do not we use hard iron? Why do we use soft iron? We said that the soft or temporary magnetic materials are easy to magnetize, demagnetize. We can easily use them to produce electricity or magnetic field for any daily usage in our lives. But hard magnetism or hard magnetic materials are very hard to magnetize and demagnetize, so it's not so easy to use them to induce electricity in another object, okay? This was episode 6, which is a summary of episode 5, and the next one is going to be a new topic, so I'll see you in that one.